All right. Hello and welcome again to this morning's webinar about automating structural engineering reports. My name is Roman Samchuk. I'm head of engineering at SDC Verifier, and today I'm going to hold this webinar. I just reshared my screen just to be sure, because sometimes when you share a window, it creates unexpected issues. So I hope you hear me well and you can see my screen. This webinar will be recorded, so for those who would like to rewatch it later, you will have such opportunity. So enjoy, and if you have any questions, we will have a short Q&A session in the end. If you have something urgent, you can directly ask in the chat or interrupt me by unmuting yourself directly. Good. So let's start. So what is the agenda of the today's webinar? First of all, we start from a very short introduction. We'll talk about the importance of reporting, structural engineering, some basics, also touching the base of delivering value to the clients through clear documentation, ways to share them, present information. There are multiple ways. The main components, the primary components of the complete report, let's call it that way, types of reports, practical process automation with SDC Verifier, and short Q&A session in the end, like I mentioned. So let's start from very short introduction, especially for those who do not know yet who we are. So we are a Dutch company who primarily does two things. First of all, we develop our own software, and we also provide engineering consultancy services. Basically, these two things are related to each other because, we provide engineering consultancy services and we use our own software. So basically, our engineers are the best testers to develop our software. Before diving into really a lot of details of the report in itself, I would like to start from something really, really basic. Because we are all involved in multiple industries. So whether it's oil and gas, civil engineering, heavy lifting, etc. And we do a lot of nice job, actually. So we do complex calculations, we create complex simulations. And eventually we reach accurate results that are really close to reality. And basically the path we go through to get to this point is pretty extensive. And I would like to quickly remind, what are the steps? What is the typical engineering workflow? So typically we need to make decision on type of calculations to conduct. So we either use software solution, or we go with manual calculations, for example, or we use both, so we just go with this hybrid approach, right? When we make decision, we start from the modeling, because I don't think there are engineers who do not use any kind of software, so typically we use it. And in order to create a model, we need to walk through multiple steps, which are inevitable. So we start from geometry, we need to create high mesh quality, play with masses, boundary conditions, basically with overall model setup, and only then we can conduct some calculations. But when it comes to calculations, basically there are also quite some steps. So we need to come up with calculation scheme, apply some loads, consider different load scenarios, conduct complex analysis. And what's more important, when we, for example, need to have a code compliance, so we need to calculate it according to standards, it brings also a lot of other issues. So first of all, we need to make assumptions on the code checking. So we need to consider multiple input parameters, conduct complex checks according to different rules, following the prescribed requirements, and then, make decision, okay, are our results within the allowable limits? After receiving those results, we get into the post-processing stage, right? So we need to create some plots, tables, graphs, animations, basically, but we need to come to the final point. Are the results realistic? So we need to make a summary and make sure what we do is the correct thing. And after this is done, basically we only then we start making a report, creating documentation. But in short, basically we create a project story. We do that to present it to our client, to stakeholder, to our colleagues, whoever, and we need to provide them with our expert opinion. Yeah, and basically after this step, I would say there is either the next steps or the closure of what you did. Yeah, so we need to make sure that our results answer the main question. So is it actually enough? This is quite a complicated procedure, but why do we do this? So that's the question I would like we ask ourselves. Yeah, because it's quite general question, and but at the same time, it's really important why we engineers do all these steps, all these kinds of different calculations. So the only answer should be, I would say, is of course to deliver value to the client. And at this point, I would like to spend a couple of minutes and think about it. Because in fact, we have two sides, the client and the engineers, what we are doing. So people come to engineers with very different questions. So for instance, someone wants to build a new design of the structure. So whether it's a crane, offshore platform, civil engineering structure, or windmill, whatever, they want to receive reliable design, which is compliant with industry standards. Someone wants, for example, verify an existing structure for any potential issues. Someone wants to extend the remaining lifetime of the structure. Someone comes to investigate some practical issues, develop solutions, and yeah, that is challenging to explain with simple tools. And sometimes we need to certify our design to get some permission. Sometimes we need to comply with codes and regulations, and so on and so on. But all these requests, they are further transferred into our engineering routine, the calculations. So basically, the reason why we do these calculations is to answer these questions. But the outcome of all these calculations is, of course, should be deliver the value. And now let's ask ourselves a question, because if people come with serious questions and we just give a short answer without any clear story behind it, basis for our decision made, does that sound reliable or convincing? Yeah, because in fact, people pay money and they expect to receive something more than just a piece of paper with your handmade sketch that is hard to read. They want to receive a story, a clear story that explains the way how you deliver this value. And at this point, I would say that the reporting starts playing a crucial role. Yeah, so this is a crucial component to make your project successful, and that is inevitable. You might say, okay, but they pay for the job done, solution developed, etc. So we spend time on this, and that's why they are paying for. And I agree, but partly. Yeah, it is important to document things, and there are reasons behind it. So let's maybe talk briefly about those reasons, because it is crucial to document everything properly. Yeah, otherwise details are forgotten over time. Imagine that in 5 or 10 years, right, like you can see over here, your client needs to revisit the same topic and recheck some details. How will they do that if it has not been documented properly? In many cases, the report is the only deliverable the customer receives in the end of the project. And often clients, they're unaware of the efforts you put in calculations, your simulations, whatever you do, and some other tasks, because this effort is not reflected in the report. Yeah, so moreover, if you personally need to get back to this topic in 5 or 10 years to verify something, will you be able to do this without proper documentation? Will you be able basically to find the latest version of your model among the 50 different iterations you created? Well, maybe then it's buried somewhere in your archives and you remember the story, the steps or technical details. Is that true? So almost certainly not, because people tend to forget what happened even a week ago. And if the project, for example, involves any certification organizations, so detailed documentation is essential. So every step must be thoroughly outlined and prove compliance with specific rules. So at the same point, when, for example, working with clients who expect outcomes to meet certain standards, detailed reporting is inevitable. Yeah, so because in the end, we need to answer basic questions. So are the results satisfying the initial request? Yes, okay, but can we see it? Where can we see it? Did we achieve our goals? Probably yes, but how did we do that? Where is this story? Did we develop our solution? All right, that's good, but how was it developed? What decisions were made in the background? We give multiple different recommendations, but what's the background? How can we check it? Is it clear what was done in general? Yes, all right, but can we see it somehow? Yeah, and you might say, you might argue basically that, well, it's not always the case because engineers often work on simple tasks that do not require extensive reporting. But are you certain that what you did is correct, basically? This is what if you can notice on this one, it's not only about the certification organizations, third party, but this is also about the quality assurance within your company. Are you sure about it? Yeah, that's a basic question, but even for simpler tasks, you need to gather details, follow some checklists, document everything. This is also kind of reporting. And if your work needs to be reviewed by your QA or quality control, they would need those details to verify your calculation. And that's reporting too. And basically that is also useful for yourself if you want to make a double check on what you did. So no matter how you look at it, it's all about reporting that adds value here in the middle. And this way or another, we need to spend time on it. This is inevitable. So let's maybe think about it. How can we deliver our information, the ways to share and present information? You might say, all right, we can just send an email and that's fine because that's the way we communicate between the clients and so on. But the drawback of all this is that you always have a limited size for emails. You're unable to attach large files, so some attachments. So that is all difficult. But what's also difficult is to manage these things, because it requires constant searching through numerous emails sent at different times, and you cannot couple the things together efficiently. What's more important, you have quite limited presentation options. So you can include basically some pictures or tables, but they most likely need to be prepared in advance because you cannot use Outlook capabilities to do that nicely. You could say, all right, but in addition to this email stuff, we have internal channels we share information through. That's all fine, but I think the biggest drawback is that your channels can be deleted at some point and then you lose everything at once. What's more important, this is also difficult to manage because it requires, again, the same searching through random messages to summarize information, to couple the things together and to create this clear story. And last but not least, this is the limited presentation option. Just similar challenges as you see with this email. You need to have a clear story. You could say, all right, I'm dealing with the FEM model, so maybe I can share directly the FEM model. I think this is not the best decision in the world. First of all, it requires specialized software. So that's one thing. Second thing, FEA knowledge and also skills for those who are you sharing this with. It often demands powerful computers. It's not a secret that we're dealing with complex models which can, have the size of millions of different elements. And you need to have powerful machines for this. You also need to have precise project knowledge. And of course, large file sizes make it impractical for easy sharing. Because it can easily take, dozens or hundreds of gigabytes. So the only and the best possible way to share and present your information, of course, through reports. It has no size limitations, so you can create files with the different sizes. You can also upload it to some SharePoint or some platform and just share the link to this document. It can be prepared in a clear, consistent story because you create your report in the way you want, so it's all consistent and it's all clear, and that is essential. You can include whatever you want, different attachments, so plots, tables, graphs, and it all nicely looking. And what's more important, you can easily navigate through these things through different chapters, bookmarks, and appropriate using appropriate fonts and so on. So since we stopped at the reporting, I would like basically also to highlight the primary components of the complete report. What do you need to show to make it complete and to make it clear? First of all, I would start from the company's information. When talking about company's information, that's about everything, basically details, information about the engineer who did this report. If you want to know, okay, if something happens, you want to know who did that. Information about the client. You want to know what are the files used for this report. Maybe you have some cross-references, some logos, some cosmetic things to make it look nicely. And after that, you typically start with an introduction. Why would you need it, you would ask? Because it reflects the complete and clear story. You need to have some background story explained. What about, what are the things you do and you show in your report? I would also highlight the request from the client itself. Because you need to highlight the goal set, the steps you need to make to come to the endpoint. Maybe reference to other documents, complete scope of work, standard use, etc., but that is all about the introduction. And then we have quite extensive things, so they're basic, but they are really time consuming. For example, full-time model description. This is exactly what was meant when dealing, for example, with any certification organizations, with any third parties, with any verifications basically within your company and outside your company. You need to show what is your model, what is the background, because showing results is not enough. People need to know what are they based on. Basically, masses, materials, shapes, plate thicknesses, any characteristics, loads and boundary conditions, of course. Basically, all set up, including the loads, factors used, and so on. These things, they define your outcomes you show in your report. So in order to make it not a black box, you need to show them. Calculation setup, of course. So you need to also to highlight any assumptions made, checks conducted, what analysis type was used, and so on. And for example, when it comes to the verification, you need to describe the checks you do. So whether it's a lifetime estimation or strength check or buckling, you need to point out how are you going to do that. When are you dealing with any kind of industry standards, you would also need to highlight what assumptions been made there, because standards are based on something. So you need to highlight, are you following all these things? What are the input parameters? And of course, what are the output parameters? And only then we can present our results. But also presenting results that shouldn't be really something that you can save time on, but you need to put a clear, extensive information using the plots, different tables, graphs, animations perhaps, and so on. And after you do that, it would be reasonable to explain your results, because again, the results you get in your report and you highlight, that is fine, but not everybody is aware of what you're showing, in fact. Sometimes you also send those reports to people who are not having this technical background. So you need to explain why something happens and what does this mean. After that, we of course make a summary of all this. So we prepare a short summary, of course, because people don't want to read all your 1,000 pages. They just need to have a really short summary to quickly understand what was done, what was initially requested, and so on. And then you also, would be a reasonable step to provide with the recommendations on the next step or any advices given on what you did. And what's more important, I think this item is really crucial. We need to translate our complex technical definitions into something simple. Again, it's not always the case that we are sharing the things with engineers with a strong technical background. We need to present things in a way that they are clear for everyone, especially non-engineers, some management, whoever it is. So they quickly can read your report, just 1 or 2 pages, and they understand what is there. And last but not least, this is, of course, conclusion. It's not a summary, but this is a short conclusion. And this conclusion should highlight a really short conclusion. What does your summary mean? Did we achieve our goal? And does it answer initial practical question? Because this is basically the only way to make sure that we deliver our value. Otherwise, it doesn't make sense to do all the things, because this is like doing calculations for no reason. We should be focused on the value we deliver, on what are we going to answer with all this, because in fact, these are the steps we came up with, and we came up with them for a reason. So, in fact, there are a couple of different types of reports we can start from. So we can either create our report manually, just with a handmade thing. We can create our full automated report, or for example, a hybrid report involving two previous ones. When we're talking about the handmade report, of course, this is unique stuff, because it's a handmade thing. So you put a lot of effort, you explain everything thoroughly, and it looks nice. But the drawback that it requires an enormous amount of time to do so, these things. If we get back to the previous step, you can see how many different items that are in fact important. And when doing this manually, this is, it takes ages. Another significant drawback is that any changes would require the entire report to be redone. Because if you change your shapes, loads, boundary conditions, whatever you do during your calculations, it influences your results. And it means that you need to update them. Are you going to do it again by hand? Well, not really. And in the end, it poses a significant risk to project success, because if you're not on time, you cannot deliver the value we started from. So will your project be successful in this case? Probably not, because if we do not deliver the value which defines project success, this is all basically useless. So in this case, fully automated report takes advantage, because it might, for example, lack this uniqueness compared to the handmade report, because sometimes when we do complete automation, it lacks this uniqueness, or we need to put some extra effort. But what's more important, it saves enormous amount of time on this. And it's easy to regenerate in case of any changes, which means that we are not posing this high risk to project success anymore. And this is basically the ideal thing for focusing on real engineering tasks and value creation. Instead of just doing this routine thing, copying and pasting something, rewrite, and then doing that again and running all in circle, we can really save this time and focus on something really important, engineering-wise important. And last report, I would say that's a combination of both approaches. So that offers benefits of customization and efficiency. So you can play with these things. Okay, what can I automate? If it's routine, think about the FEM model description, results presentation. Of course, these things can be automated. If you want to put a little more efforts into the, let's say, handmade description, some conclusion, summary, that's perfect. But it still saves you enormous amount of time. So at this point, I would like to bring SDC Verifier and to talk a little bit about it, because in fact, that includes all the steps we went through, and that brings this time saver. Because what it does basically, that allows us to create simulation, consider all these boundary conditions, loads, recognize structural items, because if you're dealing with finite elements, you need to do this in order to conduct checks according to multiple standards. It allows to optimize designs and of course generate this extensive reporting we're going to focus on today. And what's more important, these two arrows here, what do they mean? They mean that all workflow is automated. So whatever you do, it automatically updates, and these things can be redone without extra effort. So just very quickly, I'll spend maybe 5 minutes just to bring it here on the table for those who maybe see it for the first time. But when talking about simulation, of course, you are able to create complex models using different features. the one example you see in the screen, that's a basically complete ship. If you don't want to do that, or for example, you're dealing with different software, you can use them directly and just import your model to the software. Whether it's ANSYS, FEMAP, Abacus model, or some step file, this is all compatible with SDC Verifier. It allows you, of course, to apply all those kinds of fancy loads you see in the equivalent packages, and some of them are really automated. For example, complex loadings like wind, Beyoncé load, tank ballast, wave, and so on. And yeah, at this step, after the model is created, essential step is, of course, to account for multiple load cases. So you might have seen, of course, different examples of standard, like this one you see in the screen, where you have to combine multiple loads between each other, apply partial safety factors, dynamic coefficients, all these kind of things, consider different directions of wind, positions of loads. You end up with really, I don't know, hundreds or even thousands of different load cases. So good news here is that you can still use your good old Excel files, and you can just copy and paste from clipboard. But if you don't want to do that, or you never did that, you can directly create them based on the predefined load cases. So it automatically creates your load cases according to standard. Even if you have, for example, complex setup, having different positions of your load, like in this example with the crane, or you have different positions of live load, that's all doable. Yeah, and also advantage is that you don't have to open the standards anymore, because all the information about your load cases, factors, etc., this is directly accessible from the main window. So you run analysis basically, and in this case, analysis is SimCenter Nastran based. Of course, when we're talking about, for example, add on to FEMAP or ANSYS or SimCenter 3D, in addition to the standalone version, then it uses, for example, ANSYS solver directly. But when talking about the all solution in single environment, this is SimCenter Nastran based solver that includes, of course, various different analysis types. So after you did that, the logical step would be to recognize your structural members if you want to conduct checks, because again, checks are not based on finite elements. They're based on structural items like joints, connections, beams or columns, welds, panels, stiffeners, and so on. So we need to recognize them somehow in a model. And SDC Verifier does that perfectly. So it works both with on top of the simple models and, of course, on top of the more complicated ones, like in this weld recognition example, but exactly the same thing is applicable to the other ones. And what's more important, this is completely mesh independent. So it doesn't matter what mesh size you use, whether you create, I don't know, one panel with just one finite element or 1 million finite elements. This is all done correctly. So after it's done, you, of course, would like to check it, yeah, using multiple industry standards. So we have pretty extensive database, starting from multiple Eurocode versions, AAC, DNV, DIN API, ASME, etc., etc. And all these standards have basic logic. They are completely open. So it's not a black box, but you can see every single item, formula, variable. You can open it yourself and check it out. What's more important, let's say you would like to create your custom standard. This is also possible. And there are two options. One is that you just directly use the existing standard, you convert it to custom, you change the formula. Let's say you would like to replace this one factor over there. You set password protection, and of course you store it to the library to share it with your colleagues. So this is all doable. Alternative solution, you can create those basic formulas yourself. For example, you would like to create some basic check for bolts, rivets, stresses, whatever you're gonna do. You can write it your own, and it's pretty intuitive. About the results, yeah, they are presented typically with plots and tables. There are different ones, for example, like in this case for the plate buckling, For weld fatigue, idea is basically the same, and it's nicely representing the accuracy of the outcomes. Yeah. Same thing about the beam buckling or joint or connection check. So basically tables, plots, graphs, that's the way to present your outcomes over there. So after you conducted all these checks, life is hard, and it can be that you're running out of the limits. Yeah, so you would need to make some changes to your structure to optimize it actually. Yeah, because weld size might not be enough, for example. So what you could do, you can optimize it based on the different weld types, weld sizes, etc. If your plate thickness results into a buckling, you can optimize your plate thickness. If your stiffeners buckle, you can optimize shape of your stiffeners. If your beam members buckle or do not pass some basic member checks, you can optimize them as well. And this is all pretty intuitive and saves enormous amount of time. And I would say that's a game changer when you're dealing actually with the new design, when you need to come up with those things, or for example, developing solution. So after you come up, you end up basically with your outcomes. The logical step is report those things like we started from the very beginning. So this is the reporting and documentation SDC Verifier, and this is pretty extensive one. But before going to the details, I would like to highlight report types in SDC Verifier. First of all, of course, you can create it from scratch, right? So you just start from a blank page and you drag and drop things and you create your own thing. Second type of report, we call it model setup report. So it directly includes full model description for you if you want to save some time on creating those things. Third type report is results report. Idea is the same, but now it includes complete results overview with plot and tables for you. Third one basically takes into account these two together. If you want to include everything in the same document, you don't want to split it up. So it is possible. And last but not least, for those who do not like, let's say, Word or PDF versions, which are possible to use in the reporting, PowerPoint presentation. Easy. So you can use just slide, put information on top of slides, and make a nice overview in your PowerPoint. So how does it look like? When you go to SDC Verifier, before starting talking about some features, well, really nice features, I would also start from the customization, let's say the report layout, because this is important. Yeah, companies, they have internal procedures, they have internal requirements, and they would like to have their own report layout, yeah, following their own rules. So what is the height or width of your row? Maybe some report layout settings, what font you want to use, headers, footers, all these kind of things. And this is also possible. Next thing, of course, when you take a look at the left side, you can see different types of reports. So basically, just by pressing the right button, you end up with different types of reports you can access, which I mentioned at the very beginning. Whatever report you use, you go to the report designer, and that's how the interface looks like. So basically, here on top, we have different tabs. All these tabs, they provide you with different features. But before we go into them, I would like to start from something really basic, but at the same time, really important. Let's say that will be the first page, preface, and table of content. First page. Many people, they really neglect it. I don't know for what reason, but I would say this is a crucial thing. That's your cover page. That's how you're gonna present it. So first of all, you would like to know who was working on this report. Yeah, who was the engineer, company, maybe some project number, nice logo, and of course the same things about your client. What is really important here is that you don't have to fill it in each time, because you have your old library. So you can create the number of engineers within your company, number of different clients, and you can store it to your library and just use it in the future. It will be automatically represented in your report. So whatever you do, basically, you know who did this report, for whom it was done. you see all the details, and these details are accounted for in both project setup and also the report you do. So that's quite an important step, I would say, especially if something happens, for example, in the future, and you would like to know who did that, for whom, when. You have these things directly there. But this is how it looks like, by the way, when you generate it. Of course, it is completely customizable, because you're going to put your own setup over there. But the idea is that this is directly represented in your first page. Second thing, which is really useful, is the preface. I noticed that many people tend to skip it, but I would like to highlight the importance of it. First of all, it shows the unit system used. Okay, that's pretty simple, but this information on top is really crucial. Why? It shows you what software version was used to generate your report, what model file was used and the path to this file, what project file was used. It shows you when was it generated. And these things are really crucial. If you want to, for example, get back to certain steps in some time, this is the easiest way to find it out. So you know what is the version, you know the model path, for example, if you forgot or you have multiple different versions, you exactly know where to look at, right? So all info about files which have been used is shown in this chapter. Next thing, we have many different features over here. Let's say, all right, you can generate your report, export it to Word, PDF, and so on, play with unit system, number format, views, components. But if you take a look, for example, to report settings, this is something you can predefine as well. For example, the way your table's gonna look like, the way your results category is gonna look like. So all these things are also predefinable. What's more important, if you go to the page display, you can set up whether you're going to see it on 2 pages, 1 page, or you're going to scroll it. That's also a nice thing to handle quickly with the complex information. When you go to the Insert tab, you might notice a lot of nice things. So first of all, this is table of content and the preface I was talking about, but also a nice feature is the model information. It's pretty basic, but it automatically generates your model, the information about the weight, so the information about the COG, and what's really cool, the global dimensions of your model. So you see, okay, these are the global dimensions of my model. I can quickly find it out because I know, all right, my origin is somewhere around here. I know that the length of this structure is about 70 meters. I know that the side direction is about 14 meters because this thing in the middle. And I know that the height is 19, almost 20 meters. So just with a simple table, you can quickly find out a lot of nice things. Next thing is, of course, the model setup, because when you go to this drop-down list, you might notice that it contains full information about your materials, properties, FEM loads, constraints, and so on and so on. So when starting talking about the materials, it gives you complete summary with masses, with COG, with nice picture, what materials have been used in your model. Moreover, every material is highlighted with a nice table, highlighting typical properties like mass, COG, and so on and so on. And it's highlighted with the picture. Sometimes, for example, having a complex design, you might have multiple different materials, like hundreds. So advantage is that this is all automatically generated. You don't have to do it manually. And you have comprehensive information about your material model. Similar idea you have with the properties where, for example, you need to represent each plate thickness separately. So it's all highlighted with the summary table, nice pictures with the plate thicknesses you need. And of course, every single plate thickness or shape of your member is highlighted with the representative table. And believe me, but you can have like hundreds or even thousands of these things in your model. So to verify your structure quickly, this is a very good way to do so. When talking about loads, idea is pretty the same. So you see what was applied, how was it applied, to see sum of forces and moments, and it's of course repeated for every single load automatically. Boundary conditions, exactly the same thing. When going, for example, to recognition tools, because like I mentioned, we're dealing with structural items like welds, panels, beams, joints, you need to do these things as well, because you would like to highlight what are these members, like in case with these welds. For example, you did recognition of the welds, you see that here for plates, over there as well, and of course this is applicable to solids. And whatever check you do, whether it's a beam model over here, whether it's a complete vessel or a frame of your ship, it's really valuable to represent it in a report as well. Similarly, there are some additional nice features. For example, you don't have typical item to be generated and you would like to add some item from either clipboard or some additional file. This is doable. You can add text. You can sort it by different containers or chapters. Yeah, and what's also cool, there is an appendix thing which automatically gives you full description of the standard you're going to use. And depending on the standard, of course, it's very often pretty complicated. So software helps you to overcome those things. It directly highlights what has been used in your model with a reference to the standard. Yeah, including the categories for your fatigue setup. So the notch class is so-called, which is also handy. So that's a very briefly about just a FEM model description, but you can already see how much time you can basically save with those typical things. When talking about the results, of course, it's divided by the different kinds of tables. We have multiple different ones, plots or diagrams, histograms, any graphs, and of course, the same thing is applicable to your checks. So let's say, all right, I want to show results of my stresses, then I want to show results of the checks according to, let's say, Eurocode. I want to highlight what are the regions which are not passing the rules of the standard. I want to show you what is the most critical load combination. I want to give the table, why, and to where it's coming from. And this is all applicable to any kind of your results, including fatigue, let's say. Yeah. If you like to get graphs, this is also possible. Yeah, like in this case with the moment shear diagram, bending moment diagram, etc., and including the check results, like for example, your rainfall counting method or any other ones. Last but not least, this is of course tables. There are multiple table types existing in the software. So you can highlight it over different loads, components for different parameters. You can also do it for different selections. Let's say I would like to show these things for every single plate thickness, property type, part of my model, whatever. But what is really good the good way to present your results is you might, for example, split it up over the different structural parts. Let's say when seeing this upper part, sometimes you model your connections separately in detail, or you would divide them by structural components, like, for example, top node, front node, let's say some back part, middle connection, and so on. So you can also divide it over selections and present results in this way. Let's say I want to present my check results for different connections. I show it with the table, that's just a summary. And then I can do that separately, consequently after that. Let's say, okay, highlighting check results, what are the values, highlighting with the plot, you do that each one again. And advantage is that you don't have to do it by hand. You set it up just for one item and it's automatically applied to everything else. This is also can be applicable, let's say, to your platform. For example, when you want to highlight some stress results over the frames or check results over the frames or some other parameters you have in the standard. But keep in mind that every single parameter or variable used by the standard, it can be customized and highlighted in your table. If you want to delete something, let's say you don't want to see those critical stresses, they can be moved out and you can keep only what you want to see. Yeah, and yeah, this is also, of course, applicable to all kinds of selections like the frames, longitudinals, welds, and idea is that you do that for one item, and for the rest, it's automatically represented. Yeah, same thing over here, like you do it for the girder. So idea is pretty much the same. But of course, if you would like to find out what is the main load influencer on my results, so basically you want to dig deeper and to see what happens with my structure. For that purpose, we have, of course, peak finders or governing loads and free body diagram. Let's say, all right, I have my structure. I have multiple load cases like 132, but turns out that only 8 are really important, and they are here summarized with the colors. So these load cases are causing the maximum values. What I can do, I can highlight for every single load case individual influence of the loads. I see how much stress is coming from own weight, from hoisting load, from wind, and so on. And I can, of course, generate tables highlighting the percentage influence, like 38% came from the platform load in this case. It works everywhere. Idea is the same. So you highlight the value, the maximum value, or over the zone. You see what are the loads causing these values. You highlight it with the picture, see these regions, and yeah, this is doable for every single item. Last but not least, this is importing thing, because what you can do, you can import various existing items if you don't want to create them from scratch. You can import results from other projects that are not open, but you would like to import them. That is really cool. And what is handy to have is that you can link your parts or complete Word documents to the report you create. Yeah, let's say you have any kind of document, but you would like to include it by default. Let's say this is your, I don't know, disclaimer or guideline of your company. So you just link a pass and the page. Yeah, so this is about the main steps for the Word or PDF documents. But like I mentioned at the very beginning, you can also create PowerPoint presentation. And you have a wide functionality to do that. So you can make a title page, you can make a layout. And by the way, those things here, nice features. So it's exactly working like PowerPoint. So you can put some figures, making some notes, pictures from the clipboard, whatever you do. And yeah, in the end, you get PowerPoint presentation quickly done. This is how the results look like. So basically, you can quickly create some tables, directly link or plots in the same PowerPoint, so you don't have to do some manual actions. And in the end, you get extensive overview directly on your slides. There would be a logical question. All right. Do we need to do it each time? Answer is simple, no, because these steps, they don't need to be repeated every time, especially when you have similar projects, because you can create a template for your project. Something else I mentioned at the very beginning, if I have any changes, I made a nice job, right? But then we agreed with customer, with engineer from company, whoever, we need to do some changes with loads, whatever. So idea is that you do these changes and everything else is updated automatically. You don't have to do these things again manually or adjusting something. This workflow is automated and updates are received immediately. Because like I said, when you look at our workflow, you have those two arrows. So what you need to do, just recalculate your model, and this part is directly regenerated. For lazy, well, relatively lazy people who would like to have some basic templates, we also have report designer predefined reports. Let's say this is the model setup, results, and full report. So if you follow them, there is already some basic information summarized for you. So you can either adjust it or delete something, or you can just go on with the existing info you have. But idea, it already includes those things I just explained. And you can play in different overview. Let's say you can show it over loads or over selections. It's up to you, but in the end, you get extensive report, nicely summarized with the bookmarks. with nicely headings and chapters, and you can quickly get to the point where you want to get in a second, basically even having hundreds or 1,000 pages. So when summarizing all these things, I would say that qualitative reporting is a key to project success. Again, very often that's the only thing that client receives and sees, and basically that includes the story behind all these investigation or calculations we do. So this is really crucial and play a crucial role in all this. Reports typically include multiple components to ensure completeness. You've seen just how many different items you can put there, and I cannot just say that something is really negligible or you can ignore those things. I simply cannot do so, because I can tell it based on our experience. If you want to make it complete, if you don't want to end up with thousands of questions, either from your client or these third parties or whoever is it, you need to show them. It should be complete, especially if you want to store it and be able to get back to it efficiently in some time. Handmade reports are unique, but they require, of course, enormous amount of time. I want to underline it, enormous. Whatever you do, I would say it's really rarely the case. Then you do one thing and then you do it just with one run. Very often you need to redo things, to check some different options, adjust something, reinforce, change design, change loads. And it means that you need to walk through this checklist. You need to make sure it's all looking nice, or you need to present it directly to someone you want to share this report with. Automatic reports are a perfect solution, and that's without any doubt, because it saves a lot of time and it allows us to focus on real engineering tasks and value creation. People don't want to spend ages on just copying and pasting things and running in circle, because we are losing time. That's waste of time. So if we want to tailor the process, if we want to, to contribute to the value delivery, we should automate things. We should optimize it. An SDC Verifier is actually a perfect software solution that helps you to tailor your processes and automate this reporting thing. All these reports, they're customizable, can be template-based, whatever you do. So you create it according to your company rules. You can share it with your colleagues. You can reuse it next time. And this is working very, very well. So it has also extensive functionality, lots of different features. So it's up to you. You can really create a unique thing. I mentioned at the very beginning that handmade reports are unique, but this is also unique because you create a unique template and you can reuse this template. Yeah, and if you don't want to, you have also predefined reports available. Like I said, this model setup, results, or full report, or maybe some slides. So yeah, it's available in all three versions, like Word, PDF, or PowerPoint document. And what is really cool about this optimization is that you're allowed to have these last minute changes, we're struggling about, because you don't have to redo this, and all these steps, they don't need to be repeated each time. So the workflow is saved, and in the end, believe me, it saves hours, days, or even a month. And the greatest confirmation is the feedback from one of our clients. So this is Olses, who analyzed 22 models, 22 reports, over 4,000 pages created just in 2 days. And what it saves, this is not from us, but this is from them. Yeah, that's briefly it. We had limited amount of time, but I hope that I managed to deliver the message I wanted to. But still, if you have questions, we have a couple of minutes, 5 to 10 minutes, let's say. So I would be happy to answer those questions. Feel free to share them in the chat. All right, I'm going to check out if I have anything here. And I add text to the reports, or are they limited to just pictures and tables? Probably it meant, can I add text to the reports? Yes, of course. I think I mentioned it somewhere over there, but if I go to the report designer, you can add text, you can add any comments, notes, whatever you want to add. It's all accessible over there. Sorry, I have quite a lot of slides over here, but yeah, there. So any notes, any custom chapters or containers, basically you use them to make it as more custom as possible. So this is possible. What about detailed steps in the standard procedure? Can we document them as well? Probably it's meant about the algorithm and the formula. So yes, it is documentable. I was more focusing on the basic things like plot tables and so on. But of course, when you conduct any kind of checks according to rules, yeah. So when I go to this workflow over here, it includes complex algorithms, yeah, and the formulas. So you can directly extract full calculation history on paper. So you see how does your formula look like, what value was used, and so on and so on. So you see full procedure, how are you going to get to a certain value in the end. All right. More questions? Yeah, and I hope I answered two previous ones. Okay. And a quick reminder, if you're unable to share your message in the chat for some reason, you can just unmute yourself and ask it. Maybe easier. Okay. Well, still nothing. In any case, we will have a second part of this webinar today at 4, I believe. So if it happens that you you come up with some question, you can link again and ask it there, or you can share your question to our support at sdcverifier.com or my personal email. I'll be happy to answer your question. Good. Perfectly fit into our 1 hour. So thank you at this moment. And yeah, I think the best way to explore more and to see and to find out how it works is, of course, using the software. So try it out, try clicking those buttons, and make sure and experience this time saver and extensive features. So thanks again. Yeah, have a good luck, and hope to hear from you later. Thank you.